Good afternoon. It is another beautiful day in Hawke's Bay. I'll swing around. You'll be able to see behind me. Look at that blue sky. And that through there, that's Te Mata Peak, for those of you that are unfamiliar. So I'm not going to get a lot done on the trailer this afternoon, but I thought I should probably explain a bit about the MIG welder. Seeing I talked about that earlier, but it's not going to make a lot of sense to you unless you know the mechanics of the internals. So let's go and have a look at that. Before I launch into the MIG welder, I thought it may be worthwhile taking you back in time a little and talking about what predated MIG welders, and that was an arc welder. So they are these days called a stick welder, but before there were MIGs and TIGs, and all we had was arc welders, other than gas welding, but I won't bother with that today. So an arc welding rod, they come in various gauges or sizes, if you like. This is quite a small one. They always had the flux on the outside of the rod, or electrode as it's called. And so what happens is you have an earth lead that clamps onto your bit of steel, the same as you do with a MIG welder, and then the rod goes into the handpiece. And you rotate the handle and then clamp it in there, and then the arc is struck on the steel and away you go. Now the early days of MIG welders, they had an inert gas. That's what MIG, I can't remember what the first word is, but so what they did was they had a gas bottle, a regulator, and the tube, as it was, that the wire went down also had the inert gas goes down that tube, and so it creates an area around where the electrode is hitting the metal with aluminium. I think they use argon. With steel they use CO2. And sometimes they use a mix depending on what they're welding. So that was what a MIG welder was for a number of years. And then someone thought, can we do this in a way where we don't need the gas? So what they did was, and this is what I have because it's just easier, is they have this type of wire, and you'll see it says gasless up here. So what they've done is, because obviously technology has advanced a bit, and I can't get into this, let me get my knife out. So now this very fine wire, this is 0.8 of a millimeter, but it has the flux inside it. So basically, even though that's only 0.8, it has a hole down the middle that is full of flux. And so as that burns into the metal, that flux generates the gas, the inert gas, for that to work. And so that's the machine that I have. So now we'll have a look at the machine and I'll explain how it all works. So this is the inside of the machine, and the spool of wire goes on there, and it goes through here and across this roller here. Now this roller, for flux core wire, the groove is knurled, so it's got little teeth, if you like, on either side, and this side is 0.8 and that's 0.9. So it's the 0.8 that I want. So I put that on there, and then what happens is that goes on there like so, and then this roller here is pushed down on there on top of the wire as it passes through. Let me put it on and you'll see what I mean. So that needs to come off there. Now you have to be really careful in putting these on that this doesn't unspool on you, because that's not a good thing, because you can waste an awful lot of wire. So what I'm going to do is I'm going to unhook this from here, and then that needs to go on there, and then this goes on top. And then this is a nylock nut, so it doesn't come undone. Then this has to be done up tight enough. In fact, I tend to over tighten it a bit to start with until I have the wire safely in place. Because if I let this go at the moment, it's going to go ba-doing and there'll be wire everywhere. I will snip the end off that. And then this needs to go in there, like so. And then through there, and I don't know whether you can see that, there's a little hole just here, and that wire needs to go into that. So we need to get that into there like so and feed that through. Then I need to bring this down on top of it so that it can't unspring, and then I'll wind that down to about 3. So now that that is safely in there, so I know that it's all good. So now what happens is this is the other end, the gun if you like. So I need to take this off. So this is where the current goes through this copper at the end here, but I need it to feed the wire all the way down, so we'll just turn it on. Then I pull the trigger and you should see this moving. There we go. I can feel it coming up through here now. There we go. So now that that's come through, I can put this over the through here like so. Give it a little nip. And it's not, this nozzle cover isn't actually needed for the gasless wire, but I put it on anyway because it just helps protect all the end here. And I can cut that back to about there somewhere, and that's all ready to go. I'm not going to go into all the nuances of wire speed and voltage and things. There are plenty of other videos that do that. This is just a really basic so that you understand what I was talking about. So the issues I was having was that obviously as the spool becomes smaller, it requires more pull on here to make it rotate, and so that's what I needed to do. I just needed to back that off a bit when it was all the way down, and also I needed to put a bit more tension on here so that it could grip it. So hopefully that's enough of an explanation. Welding the gudgeon pins and pieces of pipe into place was a reasonably straightforward task. The hardest part was holding them in place while I tacked them with the welder. Gudgeon pin is one of those terms that means different things depending on the situation in which you are referring to them. If you were to ask a motor mechanic what a gudgeon pin is, they would tell you that it is the pin that goes through the top of the connecting rod and connects it to the piston in an internal combustion engine. Those pins are hollow and straight and are held in with circlips in the body of the piston at either end of the pin. If you were to ask a fencer, he would say that it is the pin which is attached to the post, either by bolting it on the outside or screwing it into it, that the gate hinge swings on, which is the same or a similar situation in which I'm using it here. Interestingly, if you type gudgeon into Microsoft Word, it underlines it as an error, and it has no idea what to do with the word, meaning normally you would right click on the word to see what the problem is, and it just provides no sensible suggestions, even though mine is set to New Zealand English. It's a strange thing. The welder is now working much more smoothly than it was. As I noted before, I think I had the drive wheel in the wrong way around, meaning that the groove being used was the one for the 0.9mm wire, not the 0.8, which I have, which would explain why it was having trouble gripping the wire towards the end of the spool. I didn't say at the time, but the reason the drive wheel has little teeth in the groove is so that it does not crush the wire as it pulls it through. Remember, I said it's hollow. Well, it has flux in the middle of it. If I was using solid wire and gas, which is really probably still the standard MIG configuration, then the roller groove would be plain, because you're not in danger of crushing the solid wire. The other side of the welder that I didn't show you has all the electrical bit in it. Sensibly, to make the machine a bit more idiot-proof, that part is not as easily accessible. That is almost it for today. I will finish welding the gudgeons before I knock off, but while there is still some daylight. So the gudgeons are on and the other pieces are on the front gate here. When I rested the front gate in there and clamped it in place, I put these washers underneath it just to make sure that I had clearance between this bottom gate and the top one, so that I can open and close it without too much ado. The pieces of pipe are actually a bit large, but there is a plan, because what I will do is I will put a piece of alkathene inside the pipe, and that will stop it rattling as well, which will be good. I think that's about it for today, and no light. There we go. In case this is the end of a video, which I don't know whether it will be or not, hopefully you were entertained, and may have even been some things that you didn't know, but only you know that. Okay, bye for now. See you next time.